Audio effects. You would probably have heard it in use if you listen to, say, the radio or music online, even if it's something you cannot immediately identify. As it stands, audio effects are in very wide usage, even outside of music. So, well, it probably is quite interesting to learn about some of them, especially in terms of their technical mechanics. So yeah, that's exactly what we're gonna do today. Using a free and open source software called Audacity, what we're gonna do today is we're gonna explore 4 different audio effects and try to understand in depth how they actually work. You're watching another Random Wednesday episode on 0612 TV. Hello and welcome back to another Random Wednesday episode. As mentioned, we're going to be taking a look at 4 prominent effects. Now, I use the term prominent because these 4 effects couldn't really be classified in a different manner. These 4 effects actually come at different levels of difficulty, both in terms of, the complexity of the effect itself, as well as our technical understanding of it. So yeah, these are just 4 things you are likely to hear at one point of time or another, and we're just gonna try and figure out how they work. So yeah, if you don't already have Audacity, you will find a download link in the video description. It is just an installer. Well, install it like you would any other program, and we can continue with this video. First and foremost, let us begin by taking a look at a very often used effect called filtering. A filter essentially takes all the frequencies of a piece of sound and either boosts or reduces any particular frequency. Now, just to be on the same page, let's actually try and explore the concept of frequency. As you know, sound comes to you in the form of a wave. This wave is a representation of what air is doing. In fact, sound is actually air being compressed and then moving back apart and being compressed again. And the rate in which this happens, the number of vibrations per second, is actually measured using a unit called frequency. A higher frequency corresponds to a higher pitch, and the opposite is true as well. So the low frequencies in a piece of music are normally things like drums and bass line. High frequencies are things like the hi-hats, anything that has a sharp tone. And most other things, including vocals and quite a lot of instruments, fall in what we call the mid-range. So that's a very quick crash course on the concept of frequency. Obviously, there is a lot more to be said, but in this context, we'll keep it at that. So, knowing what frequency is, we can then try to understand what a filter does. As its name implies, a filter allows you to either bring in or out certain bands of frequency, and as a direct result, influence what are some of the elements contained within a piece of music. As explained earlier, different sources of audio end up in different parts of the spectrum, and so when you do filtering, well, you actually achieve the effects of removing some of these or bringing out some of these. So in fact, in this example, we're going to look at the equalizer in Audacity, and we're going to try and apply it to a few pieces of different media, and we'll see what the effect is. The equalizer in Audacity is actually a curve. All the lowest frequencies go towards the left, and the higher frequencies go towards the right. You can use the 2 vertical sliders to actually set the maximum and minimum range. Depending on what you're doing, you might want finer control, or you might want to just go crazy and just bring everything all the way down. So let's try this on a voice sample. Let's say now if I were to take out all the bass of my voice, well, I now sound like this. I now sound like, well, all the bass has been taken out of my voice. You get sort of the radio-like feel. You can extend this further by removing all the high frequencies as well. And now I really sound like I'm talking to you through a telephone. You can do that to music as well and achieve a very similar effect. Here's a simple loop. We're going to listen to it first in its original form. Then we're going to take out the bass. And we're going to take out the treble. Of course, we can take out the treble without taking out the bass, and it sounds a little bit different. So yeah, in fact, you probably hear this effect in music quite a lot, and I'm sure if you've listened to enough music, you can even identify it, and you can probably think of some songs in which this has been used in. It's actually a really simple effect, just taking out certain frequencies. Alright, let's move on to what I would consider a more cool effect, though technically it's actually less demanding of us. This would probably be appropriately called the turntable wind down effect. Now, you've heard this before, but I'm gonna just apply it to a simple beat and you'll recognize it immediately. It sounds something like this. Of course, the origin of this effect is if you are playing a track on a turntable and you just power it off. If the turntable does not attempt to break the spinning vinyl, what's going to happen is, well, that vinyl is going to continue at its current speed and then slow down eventually to a halt. So in terms of the sound that is coming out of that piece of vinyl, well, as you would expect, you'll hear it slow down and eventually stop. And because of the way sound is encoded on the record itself, well, as this is happening, the pitch will drop as well. Doing this in Audacity is actually dead simple. Just select the area of audio you want to affect, go to Effects, and click on Sliding Timescale/Pitch Shift. This does exactly what you'd expect. You give it a starting tempo and a starting pitch. Then you give it an ending tempo and an ending pitch. If we want to do that turntable wind down effect, then our ending pitch and tempo should be lower. So, well, I've entered some values here, and there you go, that is basically the effect in a nutshell. You can also do wind up, which is basically what happens if, a turntable picks up slowly from rest. To do that, the ending values need to be normal, while the starting values need to be reduced. And basically the effect of this is you start off slow, and you work your way up. Of course, if you feel the effect isn't pronounced enough, feel free to run the effect again over that same area of the track, and well, it'll build up on top of the result of the previous run. Next up is reverb. Now, you definitely know what this sounds like. It sounds like this. It's the echoey effect you get if, you're yelling in a large room. What really interests us in this case is how we actually operate the effect itself. When you actually go to the reverb effect in Audacity, you realize that there are many sliders. I would say this is a characteristic of many different reverb plugins. You actually have a whole host of different settings you can modify, and they all change up the sound in very subtle ways. What we're going to do here is we're going to take this from the top and try to understand what all the different sliders mean. Now, if you're trying this with me in Audacity, here is one thing you should do before you begin. If you have a mono track, go ahead and double it up to make it a stereo track. Of course, it still sounds mono, but now it's 2 tracks. This is important because reverb sounds a lot better when it's stereo. When it's stereo, you can feel it really go around you. It sounds a lot more realistic. Alright, let's very quickly take the settings from the top. First and foremost is a room size, which of course affects the amount of echo you get. A small room size gives you less of an echo. This is a sample audio recording. Whereas a higher room size gives you much more of an echo. This is a sample audio recording. Moving on, the pre-delay determines the amount of time elapsed between the dry sound and the wet sound. The dry sound refers to the unaffected sound, whereas the wet sound is just the echoey part. A low pre-delay makes it sound like, well, the reverb is happening almost immediately. This is a sample audio recording. Whereas a large pre-delay gives you a little bit of a delayed feel. This is a sample audio recording. So that was a bit of an extreme example, but I hope, well, it paints a good picture here. Next up is reverberance. A low amount makes the echo sound less full, like so. This is a sample audio recording. So you could barely hear an echo there, but if I were to turn it all the way up, This is a sample audio recording. Then, well, the echo sounds a lot more pronounced. Next up is damping. With damping, we reduce the echo further. This is a sample audio recording. With everything else set to the same amount but no damping this time, it sounds more rounded out. This is a sample audio recording. Then we have the tone low and tone high sliders, and these are just filters. If I were to filter out all the high sounds, then, well, you only hear the low ones. This is a sample audio recording. Of course, the converse is true. If I were to bring up the high tones, then you'll only hear those. This is a sample audio recording. So yeah, use these sliders to, well, change the sound however you like. Next up is wet and dry gain. As mentioned earlier, wet refers to the affected sound, while dry refers to the original input sound. Use these to balance up, well, how the two things sound against each other. If you take out all the dry sound, or alternatively to doing this, you can also check the wet only box, then you'll hear just the affected sound, and to be honest, it doesn't sound great. This is a sample audio recording. Because all you hear is the echo, and that is not, well, that clear. If you were to turn up the dry, then you can hear more of the original sound. This is a sample audio recording, which of course makes it clearer. Finally, we have a stereo width slider. If you turn it all the way down, then you just get a mono sound, which makes the echo sound less full. This is a sample audio recording. Compare this to when I turn this all the way up. This is a sample audio recording. Much better. So yeah, that's all the settings you have here. Different combinations can give you a very different sound, so experiment. Alright, let's move on to our very last effect, which is called a flanger. Now, this is very interesting because a flanger is actually not an effect in the effects menu. Instead, a flanger is just how sound interacts with a copy of itself. Here's how you do it. For this example, what we're going to do is we're going to generate a piece of noise. Then, for safety's sake, we're going to reduce the volume of that piece of noise somewhat. Then we're going to duplicate it, select the new track, and actually speed it up very slightly. I have the speed up set to 0.1%, so it's a very subtle speed up. But what's gonna happen when we play it back? Well, the noise, which originally sounds like this, now ends up sounding like this. The reason why this happens is because of interference. When you mix two pieces of sound together, really all you're doing is you're adding the displacements on both those tracks. If the tracks line up perfectly, then, well, the sound is just amplified. If the tracks are directly opposite of each other, they end up cancelling each other out and you get silence. However, in the case of the flanger effect, what you're doing is, at the very beginning, well, the two pieces of sound are exactly in sync, and as a result, you just get a constructive interference. In other words, just an amplification of sound. Because the second track is sped up, these two pieces of sound are actually slipping out of sync more and more through time. As a result, different sets of frequencies in the sounds are actually having constructive interference, whereas other frequencies are having destructive interference. That particular frequency that is emphasized the most changes depending on how far out of sync the two pieces of tracks are. And as a result, well, you get this tone that is sweeping down. Of course, if you want it to sweep up, then simply shift the lower track such that their right edges are aligned. As a result, they are going to start off out of sync at first, and then become more and more in sync. If you want to emphasize the effect more strongly, you can mix down the results from your first flanging operation and basically go through the same set of steps again. The more times you do this, the stronger the effect will be. So there you go. Now, this video has run a little long, and yet all we've done today is we've taken a look at 4 different audio effects. In fact, in the world of sound, there are many audio effects that you can play with, and this is just the tip of the iceberg. But that wraps it up for this particular episode. I hope you've gained some insight and some interest when it comes to playing with sound. But yeah, that's all. Thank you very much for watching. Until next time, you're watching 0612 TV. Thank you very much for watching. If you liked this video, consider checking out the rest of my work on my channel. Alternatively, you may be interested in a playlist of my earlier work on computing and computer science topics. If you'd like to show me some monetary support, I am on Patreon. You can find a link to my campaign in the video description. Of course, you can simply like this video or leave a comment. I'll be sure to respond as soon as I can. To keep in touch with my future uploads, do subscribe to this channel. And for even more updates, check out the official Twitter account for this channel at 0612TV. Thank you for your support.